Hi friends, welcome to QuantH, a channel dedicated to exploring the fascinating world of quantum computing, artificial intelligence and human intelligence. In this video, we begin a journey from the origins of classical computers to the revolutionary era of quantum computers. So, let us discover how a few extraordinary thinkers transformed the way humanity processes information. So, first to understand quantum computing, we must first understand how computing started. Charles Babbage. He was the first person who invented the computer called difference engine in 1822, and later in between 1834 to 1837 he made mechanical computer called as Analytical Engine, which included arithmetic logic unit, memory and punched cards. So that's why we call him as father of computers. Alan Turing. He invented computer science in 1936. November 1945, the electronic numerical integrated analytical computer, in short ENIAC, by John Mauchly and P. Escott at the University of Pennsylvania for US Army. After so many developments on that machine, now we are calling that machine as classical computers, which is an electronic device, takes input data or text as a bits. Bits are either 0 or 1 and process arithmetic and logical operations on the data and gives output as text. So, this system has the ability to store the information and retrieve the information and process on data. Now, coming to the topic of quantum computing, how it came to exist nowadays. The quantum era started in 1900 by Max Planck. He stated that energy is emitted or absorbed in tiny packets, means small packets, which we call as a quanta. So that is the first word came into existence. In 1905, Albert Einstein taken the statement of Max Planck. He proposed that light itself is made of tiny particles called photons, and later proved that light has particle nature, that is photoelectric effect. Later in 1924, Louis de Broglie formulated electron diffraction. It means electrons create interferences like waves. In another way, if light waves can behave like particles, why can't particles behave like waves? Based on the Louis de Broglie statement, Erwin Schrödinger in 1926 he found the wave equation. This wave equation gives the probability of finding the particle at a place. Based on Schrödinger's wave equation theory, started the birth of modern quantum mechanics in 1926. This time, Heisenberg, Born, Dirac and others scientists developed the full theory of quantum mechanics. Their theory based on why atoms have discrete energy levels, similarly how electrons behave in atoms. So, based on the results of so many experiments on this theory, finally quantum mechanics is now the function of modern physics, technology, electronics, lasers, semiconductors, MRI, quantum computers, and much more. Based on the theory and so many experiments, finally, the key point of this conclusion is nature is quantum, energy, light, matter. Everything works in tiny discrete chunks or particles. Benioff and Richard Feynman proposals. In 1985, David Deutsch, British physicist at the University of Oxford, formulated the description for a universal quantum computer and specified the first quantum algorithm. In recognition of his work, he was awarded the Breakthrough Prize in Fundamental Physics in 2022. Later, in 1994, Peter Shor discovered a landmark quantum algorithm for factoring large numbers. After 1994, till today, means 2026, nobody came forward with any development in quantum computers. In a quantum nature, we are the humans living, so we are the quantum humans. May you are the first quantum human with your innovations and ideas and further developments. Total quantum world and quantum future generation, quantum humans are eagerly awaiting for your innovations and your proposals. Hope you can do it. Best of luck. Still in development stage of quantum computer. Now let's see what is quantum computer. Quantum computer, it is a new type of computations or work that uses quantum mechanics tools such as superposition, entanglement, and interference to perform calculations. It takes input data or text or information as qubits. Qubits like a bits in classical computers. In classical computers, it takes either 0 or 1. But in quantum computers, the qubits are 0, 1 or combination of zeros and ones. It means multiple of zeros and ones it takes. So now what is the difference we find out? Classical computer will take either 0 or 1, means only 1. In quantum computer, it takes multiple. Now see that table. Let's see the difference between classical computers and quantum computers. Now first one, information. Means how the systems will take the information. In classical computer, it takes bits. Bits means either 0 or 1. It means only 1 it will take. When come to the quantum computers, it takes input as qubits. Qubits means 0, 1 or combination of zeros and ones. It means it will take information multiple. It means multiple works or multiple processing. Okay. Now let's coming to the processing. How the processing will be. In classical, the processing will be sequential, means step by step, means one by one. But in quantum computer, it will go parallel, means one time it will do number of works simultaneously. Got it? Now coming to the power scaling, means how we can make the speed of the systems. When it comes to the classical, it will be the linear. Means when you add more bits, that will give you more power. When it comes to the quantum computer, you are going to use exponentials power. It means doubles its power. Next coming to the concepts, underlying concepts and the systems. Now in classical, The concept is physics. It means voltage and charge. When it comes to the quantum computer, here we are going to use the concept of quantum mechanics. It means electrons and protons. Hope you understood. Now, what type of environment required for the both systems? In classical system, in general environment means standard conditions. When it comes to the quantum computer, we need extremely cold and isolated from the noise. Means it is closed, like a closed room or closed box. We will discuss about that. Now, coming to the applications. What type of applications or work can be done on these systems? When it comes to the classical computers, just we are going to streaming or emails or general computings. When it comes to the quantum computer, it is a special simulations or optimizations or more complex computations. From this tutorial, we came to know finally classical computers will work one by one sequential and quantum computer work multiple works at a time, means parallel. So remember these two concepts. It's very important.